in SVCE Engineering College, 5th SEM Bhaskaram. The subject is Computer Networks and subject code is PCS 502. And today I'm going to explain about TCP or IP model in data communication and network. TCP is full form is transmission control protocol, and IP is the internet protocol. So the introduction of that is the internet protocol suits commonly known as TCP or IP is a critical framework for data communication networking. This presentation aims to explore the operation and models of the TCP or IP suite, underlying principles, and comparison with the OSI model. OSI is the full form is Open Source Interpreter. The TCP or IP overview. The TCP/IP consists of two primary protocols, that is Transmission Control Protocol, that is TCP, and Internet Protocol IP. As I told in first slide only, packets are assembled and routed through network host. Packets are nothing but the connections between the one devices to another device, or the connection between the one node to another node of uh, movement of the signal will be called as a packets. Next is architectural principles. We have end-to-end principle and robustness principle. End-to-end principle is nothing but intelligence is retained at the edges of the network. Robustness principle is nothing but the conservative in sending and liberal in receiving behavior. In TCP/IP models, we have 5 layers mainly. They are data link layer, internet layer, transport layer, application layer, and the physical layer. Link layer manages communication technologies for a single network segment. Internet layer establishes internetworking and addressing routing. Transport layer facilitates host-to-host communications. Application layer provides process-to-process application data exchange. And we have another layer, that is physical layer, which will be done after the layers of the layers in the TCP models communicates with each other to transfer a message from a sender to receiver. The last layer will be the physical layer, which in that the bits will be called as an messaging part, and that bits will be transferred from sender to receiver. Then it will be transported from a physical layer to application layer, transport layer, internet layer, link layer, and then the receiver will receive the messages. Data encapsulations. Data encapsulation occurs as packages are assigned headers at each layer. Different terms are used for packets as they pass through the TCP/IP stack. Comparison with OSI model. TCP/IP combines the application, presentation, and session layers of the OSI model. Like in TCP/IP we have like a 5 layers, but in OSI model we'll be having 7 layers. As I seen in previous slides, TCP/IP layers will be having link layer, transport layer, application layer, internet layer, and physical layer. And in OSI model we have having Same application, link, transport, internet, physical layers, and except that 5 will be having additional 2 layers, that is presentation layer and session layers. Emphasizes simplicity over strict hierarchical layers. Network addressing translation. This addressing translation allows multiple hosts to share a single public IP address, facilitates IP address renumbering when changing ISPs. The conclusion of this presentation, and these presentations are all taken from the mainly 5 or 6 research papers, and I um, combined all the all the research papers to one presentation, and this is the conclusion of that. TCP/IP has evolved from its origins in the ARPANET plant and remains foundational to modern networking. Its layered structure and principle supports versatile and robust data transmission. The main conclusion of this presentation is ICP/IP continues to be pivotal in networking. Understanding its components and operations aids in grasping modern communication. So, this TCP/IP will be in our OSI will be used in the communication between uh, a system to our the network to the servers, or system to servers or networks. So this is basically used for the networking purposes. So references, which have took the references for to make this presentation, that are Zaman S and Karai F 2009, Fuzzy ESVDF approaches for intrusion detection system, and ONET I and Corbani A 2007, a future classification scheme for network intrusion detection, and Tamilarasan A, Mukkamala S, and Sung A, and Kendrapalli K 2006, future ranking and selection for intrusion detection using artificial neural networks and statistical methods. These are the references I have taken for this presentation, and I have took some other research papers also and the others will be the same, um, to prepare this presentation very nicely. So thank you very much for listening to my session, and making the session very nicely. Thank you so much.